consultant. And so basically I'm a technical kind of guy. I spend a lot of time talking about pressure-independent valves and the impact they have on your systems. I've been working with Belimo for most of my adult life and in the control valve business that entire time. So hopefully I can answer all the questions you may come up with today. We're very excited to introduce a new product that's in the process of being released right now. It will go under the trade name of PIQCV. And the PIQCV is a pressure-independent zone valve. It is designed for low flows and small sizes. It's a very compact valve. It's a very inexpensive valve, and we're pretty excited to share that with you today. So let's go ahead and get started. As Michaela said, we will have a question and answer session at the end through the chat device. So please hang on to your questions, and we'll be happy to address them all at once. The PIQCV. All right, I think whenever we talk about PI valves, it's important to discuss really what we're talking about in terms of pressure independence. And so what a pressure independent valve really is a two-way valve that gives you a specific flow value or a specific GPM for each value of your control signal. So a standard control valve, for each value of your control signal, your valve opens or closes to a certain degree. So the opening or the area, the surface area that's exposed for the water to go through gets larger or smaller. In a pressure-independent valve, we get much closer to what we're interested in controlling, which is how much water is going through our valve. And so this is a real high advantage. So we're looking at two-way valves where we're getting a specific GPM for each value of the control signal, and that's regardless of the pressure fluctuations throughout our system. So what is the PIQCV? Well, the PIQCV is a compact pressure-independent zone valve. It is built on the Belimo CCV technology, which is the characterized ball valve. It is quite small in comparison to other Belimo PI valves and other PI valves in the market. It has incredibly low power consumption. It's completely field adjustable, and it carries with it Belimo's 5-year warranty. So let's go ahead and break this down a little bit. What's the big deal about having CCV technology? Well, at Belimo, we're a firm believer in utilizing the ball valve technology. We characterized the ball valve in the late 1990s when we invented the CCV. And up until that time, pretty much everybody was using globe valves for control. Well, we were able to take the ball valve, which is inherently less expensive to manufacture, has a higher close-off rating, and the rotary action of the ball valve is right in line with the rotary action of motorized actuation. You know, motors turn in circles. It's quite difficult, actually, or it's not difficult, but it's complicated to get a rotary motor to create linear motion. It's much simpler to get it to create a rotary motion. So that's why Belimo bases all of our valve development around rotary style valves. I said earlier we get nice high close-offs. On the PIQCV, you will see 100 PSI close-offs, and we'll have no leakage with them. So those are bubble-tight close-off ratings, unlike the close-off ratings you'll see on globe valves are typically defined at an ANSI Class 3 or ANSI Class 4 close-off. And the ANSI Class 3 and 4 defines how much water is leaking. Well, in ball valve technology, much like a butterfly valve technology, these valves are rated as bubble-tight, which is just what it sounds like. There's no leakage, and you can't even pass air through them at 100 PSI. So we've built it on this technology. You can see a nice cutaway of the valve. You can see, like most pressure-independent valves, the internal workings are a little complicated. It's basically two different devices built into the same housing. So on the left side of the valve housing, you see the ball and the stem, so that's the control valve. And then on the right side, you kind of see a spring and some moving parts in there, and that is the pressure regulator that ensures that we get constant flow. And we will take a look at how this valve operates a little later on in the presentation. Let's talk about the size, because I keep telling you how small it is. Well, this is a picture of Belimo's PIQCV with an LR series actuator on it, and you could see that it measures out pretty big. It's over 7 inches tall, and it's almost 8 inches long, although the length tends to be less critical because that tends to be in line with the pipe. But we're certainly worried about the height, especially for zone-level applications. We're talking about putting valves in cabinets or in crowded plenum areas. and so we wanted to get the size down. So Belimo made efforts to use the KR series actuator, which is much slimmer on the PIQCV, and we did this a year or two ago. And you can see we were able to cut a couple inches off that height. But the PIQCV really takes it to another level. You can see that this valve is just barely over 4 inches tall, so it's almost 3 inches shorter than the original PIQCV assembly, and so it's quite tiny and quite compact. In fact, it is 65% smaller footprint area-wise than the original PIQCV. So again, for these low-flow zones, we're trying to get this inlets into our reheat coils on our VAVs. We're trying to get them into our cabinet units, into our fan coils. These are typically tight spaces, or the inlets to them are crowded. This allows us a much smaller product to get in there. The PIQCV also has quite a special little motor on it. This is a brand new actuator from Belimo. It carries a torque rating. I should know this off the top of my head, and I don't. I don't know what the torque rating is. It's enough to turn the valve, that's for sure. I believe it's about 18 inch-pounds, but I could be wrong on that. It comes in non-fail-safe or fail in last position. It also has a fail-safe version. This does not include a mechanical spring. It has a supercapacitor in it that allows for fail-safe operation. That's a really nice feature that Belimo's developed over the last 10 years or so, whereby the capacitor stores enough extra electricity that when the power fails, we can drive that valve either open or closed or really anywhere in between. And so it allows us for very versatile fail-safe activity. One of the other nice parts about this motor is it has an exceptionally low electrical draw on it. It actually only requires 3 watts while the motor's running. So this is very minimal. It obviously saves some energy, but it also increases your transformer capacity. In other words, you can put a whole lot more units per transformer than you could with a standard valve. And so let's kind of take a look at that. The KR series, which we talked about before, was that sort of slim actuator, or the LR series, which is the original one, take between 1 and 2 watts per valve. So you could see that based on a 6-watt output of the LR series, you can actually wire up 6 of these PIQCVs for the equivalent power draw as you would from the LR series. And Belimo is fairly efficient even then. Some of our competitors are listing electrical demands in the 3.5 to 7 or 8 watt range per actuator. When you start looking at that, if I have 300 or 400 valves in a large building, times the energy savings we're looking here, it actually starts to add up to numbers that might be valuable to the owner. The other part about the PIQCV that's really nice is the field adjustment is very straightforward. What you're looking at here is a picture of the underside of the actuator. That little T section or cross section in black in the middle actually is the part of the actuator that mounts with the valve stem. And you can see there's a little panel, for lack of a better word, and it's numbered 1 through 6, and it has different gradations, and this is how we'd be able to set the flow. So let me bring up the little chart here. This is a clip right out of our technical documentation, so it shows you how to do your field adjustment from the bottom. And each one of those positions, 1 through 6, or N, which is nominal, or if you take the clip off altogether, all have different flow ratings. So you can see we have 3 valve bodies in the 1/2 inch size here. The max flow on the smallest valve would be 0.9 gallons a minute. That'd be if you remove the clip altogether. And then you could put the clips in the different positions to match the flow requirement of your coil. One thing I like to point out here is that the flow can be set very low. So in the last few years, we've seen a trend towards very low flow demands on VAV reheat coils, 0.2 of a gallon a minute, 0.3 of a gallon a minute. That was the specific purpose of designing this smallest PIQCV valve, was to address those particular types of applications. And you can see here we can control it 0.1, 0.2 gallons a minute. There are notches in between the numbers, and so you can actually do much finer adjustment if you needed that. Within the technical documentation, we'll provide these graphs. So this takes a look at, in this case, is the 1.9 GPM valve, and that's the characterization curve of that valve, and it shows you all the different positions on which you could set that. So just for example, if I needed 1.2 gallons a minute, I would just trace it across from the right-hand side and then down to the bottom here, and I would see I would go to the number 6 and then move it one more notch around the circle there to get 1.2 as opposed to 1. And then also, if you look up, if you trace that line up the graph, it'll show you the actuator runtime if you reset to that position, and that obviously would be very helpful if we were doing a floating point application. We need to know the runtime of the new set. So if you're out in the field and you want to set this and you don't have your technical documentation with you, oh, I always forgot my little chart here. All right, so we put the 6 and then we moved it up one notch. So if you don't have your technical documentation with you, Belimo has given you a few more tools. What you're looking at here is the zonetight.com website, and it has a flow tool, and you just click on modify your flow capacity right there on the screen. It pops up a little window, asks you what flow you're looking for based on the valve you have, and then it tells you what position and even gives you a little picture of it. There will be an iPhone and Android app for this as well, so you can keep that right on your phone when you're doing these resettings. So we've tried to make it simple enough to access this information and keep the product versatile enough that you have in a large number of set points that you can try to utilize to get the exact flow that you need. One more thing that comes into play when you're not in the floating side, but when you're using modulating actuators, so the SR version or the 2 to 10 volt version of the actuator, they have an adaptation button on it. And so once you set your clip position, you hit the adaptation button one time, and the actuator will rotate itself until it hits the end stop on both ends, and then it will rescale the control signal over the new range. So you don't lose any of your control resolution just because you set your 0.9 GPM valve, you only really need 0.6 GPM. Now 0 to 10, or 2 to 10 rather, would be between 0 GPM and 0.6. And so we don't cut off any of our control resolution, which always helps us out. All right, so we talked a little bit about the features of this product. I always like to give people an idea of how a pressure-independent valve works because, well, frankly, I'm kind of a nerdy valve guy, and so it's fascinating to me. But the more I talk about it, I tend to hear people think that it's interesting, at least to some degree. So let's take a look at this. So there's our cutaway. I'm going to give a little schematic here that might be a little easier to see. So you can see that water flows left to right through the model that we have here. And you'll notice that I have these P numbers. Now, P1, which you see on the right side of the valve there, whoops, represents the inlet pressure. Let's go ahead and do the breakdown here. We kind of talked about this before, is that the left-hand side of the valve is the ball valve part, and then the right-hand side is the pressure regulator. So the job of a pressure regulator in a pressure-independent valve is to ensure that the pressure drop over the ball valve is always constant. That's how we make the valve pressure-independent. Essentially, the regulator consumes the excess pressure and leaves only the same amount for the ball valve at all times, and that's how the valve becomes pressure-independent. So again, let's take a look at this. P1, as I started earlier, is our inlet or upstream pressure. It's the valve, the pressure that arrives at the valve. And then we're going to define a second pressure, and we're going to call that P2. And P2 is the pressure inside or after the effects of the regulator. So as the water sneaks through this opening here at that zigzag right before it says P2, just to the right of P2, the water kind of sneaks in there. Well, it takes a pressure loss when it goes through that small area, and we can adjust the amount of pressure that is consumed by making that area larger or smaller. So right now, there's a fairly large opening to let water into P2, and then as the regulator moves left to right, that area will open or close. And I have a little animation I'll show you on the next slide that might help you visualize that. So P2 is the pressure after the effects of the regulator. And then P3 is going to be the pressure after the effects of the ball valve. So P2 and P3, or the difference between P2 and P3, is how much pressure drop the ball valve or the control valve sees, and that's the number we need to keep constant in order to maintain pressure independence, is the pressure differential between P2 and P3. And the way we do that is by sampling P3 on the opposite side of a diaphragm of P2, and so that when those numbers change, they can modulate their position mechanically and make sure they stay constant. So what we're going to do is we're going to sample P3 back here in this little chamber. And then on the next slide, when I animate, you'll be able to see how when P2, or more accurately, when P1 gets larger and then P2 gets larger, the regulator is going to shift so that the differential between P2 and P3 stays consistent. So let's go here to the animated slide, and you can see again on the inlet or right-hand side of the valve, we have P1, we have P2 inside the regulator portion after the effects of the regulator, and then we have P3 in a couple of different places because we sampled that pressure. And then if we increase P1 and P2, we can animate this, and what's going to happen is that P2 now pushes to the right, basically, on the regulator against P3, which is pushing to the left. And then if the differential is that P2 is significantly stronger than P3, it'll compress the spring. It'll create a smaller area for the water to sneak into the regulator, which means that it'll take a larger pressure drop, and then it'll start to balance itself out. And so as this runs with water through it all day, it's a highly dynamic system. So it's constantly in motion. The spring's compressing or decompressing depending on the changes in pressure. And so that area that the water sneaks through before it gets to the ball valve gets larger or smaller, just depending on the increase or decrease in pressure in that line. The whole essence, whether you understood most of that or not, is not terribly critical. But what's most important for you to understand, and I'm going to go back a slide here and click here to this. What's most important to understand is that everything that's in the right-hand box ensures that everything that happens in the left-hand box looks the same all the time. So we've taken what amounts to a standard CCV and just guaranteed the pressure drop through that ball valve. Once we guarantee the pressure drop, we can guarantee the flow. And that's how this PI valve works, and frankly, that's how every PI valve works that is mechanically regulated. So Belimo has a line of electronic pressure-independent valves which use flow meters. It's completely different than this. But the PIQCV, which is the sort of predecessor to this product, and all mechanical PI valves made by other manufacturers essentially use a similar type of technology. All right, let me get back to where I was. I skipped here. So what does this look like from a product standpoint? Well, the PIQCV comes in a fully assembled product here. We get the valve and the actuator. You can see that there will be 3 valves available in the 1/2 inch size. And so just for transparency, Belimo will release the 1/2 inch version of the PIQCV this year. We will follow up in 2016 with a 3/4 inch version of this valve, but that will not be available in this year's catalog. So there's 3 valve bodies. The largest is the 4 gallons a minute, and then the 1.9 and the 0.9. And as we looked at earlier, all of those can be scaled down from there. So if you needed, say, 2.3 gallons a minute, you get the 4 GPM valve and reset that position for 2.3 gallons a minute. It's an interesting assembly. There are no tools involved for removing the actuator from the valve. You just kind of yank on it and it pops off. The nice part about that is that the actuator becomes the handle for the valve. You remove the actuator, you set it back on the stem without clicking it into place, and you can rotate the ball. So if you're doing a flush of your system or you need that valve opened in a hurry for some reason, it's quite simple to do it. As we talked about earlier, the field adjustment for flow is relatively straightforward, and these carry, as all Belimo products do, the 5-year warranty. Okay. We are going to sell a couple of accessories, not a whole bunch of stuff that go with this, but one of them is a stem extension. Part of making this valve so compact means that if you want to insulate your piping, it may get in the way. And so we've given the option for a stem extension. It gives you about another inch of clearance so that you can wrap your pipe and still have the actuator above it. We never want to insulate an actuator. It could cause problems with the actuator overheating. You know, electronics just kind of need to breathe, so we don't want to do that. In addition to that, we're also offering a flow orifice device with this valve. Sometimes people require, an engineer might require that there's direct flow verification on the valve. Most PI valves cannot be flow verified with the equipment that's installed on them. This valve is included in that, and so if you wanted that flow orifice device, that could be provided as well. Just wanted to give everybody a look at the specifications of this valve. It's fairly robust. It is a forged brass body, but has a stainless steel ball and stem. The characterizing portion of this valve is integrated directly into the ball. So if you're familiar with Belimo products, they're used to, in many of our products, there's a characterizing disc. It's sort of a plastic piece that sits in there that does the characterization. For this valve, much like the electronic PI valves that we make, the characterization is integrated into the ball valve. It has a maximum operating temperature of 212 or 100 degrees C. It is rated up to 250 in that the valve will not fail at 212, but we're going to stop warrantying it if you're running 250 degree water through there. So the warranty carries to 212. In addition, there's two PT ports on this valve. The PT ports are for verifying that you have the minimum required pressure drop. One of the great misconceptions about PI valves is that the two pressure ports that come on many PI valves can be used to verify flow. That indeed is not what they're there for. They're there to make sure that you have the minimum pressure drop requirement to become pressure independent. In this case, this valve, much like the PIQCV, is pressure independent from 5 to 50 psi. The installation's pretty straightforward. Just like any other Belimo valve, you can put it in a riser up or down. You can put it in horizontal piping in any configuration as long as the actuator is not below the valve. This is pretty straightforward. This should go for any manufacturer. You never want to put the electronics below where the water might leak from or condense from, and so we always like to keep the actuator not below the pipe. We got a question even before we started in regards to pricing, so I'm glad I put this slide in. This is a cut right out of the Belimo 2015 product guide and price list, which is available online, or we'd be happy to send you a paper copy of it if you would like one. The pricing for the PIQCV is rather aggressive. So you could see that the floating version lists at about $350. And the modulating version is just a little over $410. If you know what your multiplier is, feel free to add that in and you'll have an idea of what this would cost you to purchase direct. If you're not a direct customer of Belimo, feel free to contact whoever you do buy from and they can help you with pricing on that. For a frame of reference though, the PIQCV with similar capabilities to what the PIQCV would be, lists for considerably more. So what I'm going to give you is the pricing on a half-inch PIQCV with an LR modulating actuator that's field settable, and the list price there is about $577. We can get up to $650, even close to $700 on PIQCVs. So you can see this is a substantial price decrease. I recently did a pricing exercise with one of our good contractors based on his multiplier, and the PIQCV actually wound up being about $20 to $25 more expensive than buying a CCV of similar capabilities. So that is $25 more than a non-pressure independent valve. To put this into perspective for you, that would mean that if you wanted to buy a CCV and put a balancing valve next to it, you would need to be able to buy that balancing valve and install it for less than $25. I doubt highly that you can do that. This product will be priced aggressively enough that there really will be no reason to not use it. It will be less expensive than the pressure-dependent solution on an overall project level. So if you have more questions about pricing, go ahead and call your sales manager at Belimo or whoever you buy Belimo products through, and we'll be happy to break this down a little bit further. In terms of availability, We actually have some of these valves that we're shipping currently. In fact, we have the two smallest valve sizes, the 0.9 and 1.9 GPM valves, have some limited quantities, but are available now. If you call and order 700 of them, we probably won't be able to satisfy that order right now. But if you need 30 or 40 of them, please give us a call. We'd be happy to send them to you. The full product release will be, well, if you call Belimo, they'll tell you July. I've worked for Belimo long enough that it might be somewhere between July and August. We'll have full quantities of all the sizes, including the 4 GPM. Now, as I said earlier, remember that next year, in 2016, we will be following this product up with a 3/4 inch versions. We have not finalized all the flow capacities on those as well, but the full product offering as we go forward will be 1/2 and 3/4 inch valves in this particular style. We mentioned zonetight.com earlier and belimo.com, which either website has tons of information in regards to the Belimo ZoneTight. So I encourage you, if you'd like to read a little bit more about it or download a price sheet or download the technical documentation, there's quite a bit of information on zonetight.com, as I said, including the specs, all sizes and dimensions, and all the specifications you might need. We have plenty of documentation to answer all your questions, and we're always happy to have you call us directly as well. So thanks so much for joining me today to talk about the PIQCV. We're very proud to introduce this product. Just as a reminder, we're using that CCV technology. The valve is 3 inches smaller top to bottom than its predecessor. Super low power consumption, field adjustable, and that Belimo 5-year warranty. At this point, I'd like to open the floor up to any questions you might have. Michaela has put the chat window back in the bottom right-hand corner where you're looking, and please feel free to provide some questions if you have any.
Thank you so much, David. In the meantime, while you're thinking of those questions, I do want to point out that we have some downloadable files in which you can take advantage of today. So if you look at the upper pod, we have the ZoneTight valve brochure and the tech doc. Also some links to the ZoneTight website. Our first question, are PIQCVs going to be available in piping packages?
That's a great question. I don't know the answer to that. I don't think right away. I mean, if you called and asked them today for them, I can guarantee you they won't have them. I think over time we'll definitely consider to put them in there. It's really a perfect match. So I'm going to say not right now, but if we're not planning on doing that, I'll make sure that we get it on our radar. So thanks for the input.
David, just to follow up on that, I did just get confirmation from our product manager that they are, in fact, going to be available in piping packages.
Well, they're fantastic. Michaela has the advantage of sitting in the Belimo corporate office, so she can just shout across to those guys. I am all the way out in Denver, so I was not able to get that. Thank you, Michaela. Appreciate that.
You're very welcome. I have another question coming through. Does the valve and the actuator come assembled, or do they have to be assembled in the field?
So as I said, the assembly of these things couldn't be simpler. You literally take the actuator and push it down on top of the valve. So when it comes to you, it should come assembled, but for piping purposes, usually the actuator gets kind of pulled off the valve and then assembled or installed piping-wise, and then you can snap it right back on. We designed it in such a way that it's so simple that it really doesn't matter, but it will show up packaged together.
Great, thank you. Next question, are you offering a readout meter?
If you mean, are you asking about a digital flow meter? If you're asking about a digital flow meter, we don't have anything in conjunction with this product that has an electronic flow measurement device. We do have the orifice device that we discussed earlier that will be available with this product.
And David, to follow up with that readout meter question, Bill Brennan is saying for the differential taps.
So again, the differential taps are for reading whether or not we have 5 PSI. So I don't think we're selling anything to take that reading. I would imagine your installer or your tab guy has that type of equipment.
Okay, great, thank you. Next question. What is the electrical power requirement of the actuator, 24V or 120V? And what is the valve size range again?
Excellent. They are all 24-volt actuators. I should have started there, my apologies. So all the actuators on the PIQCV are 24 volt. The valves at this point are all half-inch, but the size, there's a few different size ranges. Let me just back up a few slides. There we go. So these would be the 3 valve bodies that are available right now and the flow measurements of each of them. So we have a 4 GPM valve, and then as the largest, and then the smallest is 0.9, and they can all be set lower from there.
I'm also getting word that we actually have 110 to 230 volt actuators available as well.
All right. Well, look at me being underinformed.
Floating point.
Are those in the book? I'm just gonna check my catalog while we're sitting here.
I don't believe they're in the book.
Okay.
Okay.
So if those are needed, please let us know.
So next question is from Mary A. Is there a gasket or ring that will be replaceable where the actuator goes into the valve?
So no, there's no replacement parts on it. So the way that Belimo ball valves are designed is that all the sealant that seals the water from coming through the stem is internal to the valve, and so none of that is replaceable. Belimo has sold something like 4.5 million ball valves in the past 15 years, and we have a pretty good technology that we're comfortable with in terms of keeping the water in the pipe. And so those are not replaceable.
Okay. Can the fail-safe units be used as on-off application?
Yes, they certainly could. Remember, the fail-safe works using a supercapacitor, so there's no reason you need to modulate these valves whether or not it has fail-safe or not. You can drive it from all the way closed to all the way open, and then use the supercapacitor to fail in whatever direction you want. So it's a little different than the old style 2-position spring return actuator where you give it power and it drives open, and then you cut the power and it springs closed. This one, you could tell it where you want it to go. I mean, theoretically, you could cut power, but you don't have to.
Well, we have a couple more questions coming through. I just want to also remind you that this webinar is being recorded so that we can use it at a later time. If you're interested in getting a copy of this webinar, feel free to email us at marketing@us.belimo.com. Or if after the webinar you come up with a question, feel free to give us an email and we'll try to answer your questions. Okay, so next question is from Bill. Stainless ball and stem on the new valve PIQCV is chrome plated?
Good question, Bill. I'll be perfectly frank with you. There's no need to have a stainless steel ball and stem in this application. However, plenty of engineers are writing a specification that say they want it. From an application standpoint, it's somewhat irrelevant, but this is just so that we don't have to fight specs and try to convince everybody that we need that. So we got a little pushback over the years on PIQCV, and we just decided to go in a different direction. It's unnecessary for the application, though.
So the capacitor won't fail over time?
The capacitor is designed to outlive the lifespan of the actuator, so we certainly hope it won't fail over time. One of the original, so capacitor use in actuators sort of had a nasty history, if you will. 15, 20 years ago, this was tried, not by Belimo, but other people, and it was a mess. The technology of supercapacitors has changed so much in that time, and Belimo spent about 5 years of research and development making sure that when we put a supercap in an actuator, that was not going to be the fail point. So I wouldn't have any worries about that.
Great. Next question. Will there be a 110 or 220 VCA version in the future?
Well, apparently, according to product management that we just found out from, we have one of our universal power type actuators, which we call a UP, which will do anywhere between 110 to 220 or 230, which we can put on this valve now. It doesn't appear in the catalog, so we'll work with your sales manager if that's a requirement, but apparently this is something we could do today.
Okay, it looks like we have answered all questions today. So I want to thank you once again for participating in the Bulima webinar series. Thank you to David Kandel for being an excellent host. And if you should have any further questions about the PIQCV, QCV, or any of the new zone-tight valves, please feel free to contact us at marketing@us.bulima.com. Everyone have a great day.